So next in line we have Ronald HARASIM. He's an expert in AI, in IT and AI, who started programming at a very young age. Ronald has studied diverse range of fields, including IT, law, classical archaeology, philosophy, mathematics, physics, and has founded his own IT company. Currently, he manages international IT corporation. He works in company, yeah, thank you, and works part-time at the Institute of Archaeology at the Czech Academy of Science. Please join me in welcoming Ronald HARASIM.
Thank you. So today I want to talk about how we process data, our archival data in our institute in Brno. First, I have to explain how it works in Czech Republic in a very simplified way to understand the background of data we are working with. So, with very simple terms, there are just 3 steps. We do the excavation in the field, we made some analysis, interpretation, made photographs, collect some data, and made fieldwork report. And then all these data are sent to the central evidence to our archaeological information system of Czech Republic, where we collect all data from all excavations that took place in Czech Republic. We also have digitized data from over the last 100 years. We have over 150,000 photographs and 1 million plus pages of documents of old fieldwork reports and notes. These data comes with some metadata like author, the time when it took place, geolocations, etc. So the first step was to digitize these negatives and kinofilms of these photographs into JPEGs or some TIFFs, and also digitize the old documents into photographs. But these are only human readable data because it's only the picture, the scan of the document. So computers are not able to process it or read it. So the first step we did, or we are going to do, is to make optical character recognition. So we can extract the text from these scanned documents into machine-readable format. We are using a combination of technology like Tesseract OCR, that is open source library from Google, also Keras optical character recognition library that uses a different approach than Tesseract OCR. And lastly, large language models, the multimodal solutions that can extract more difficult text from these scans, like handwritten notes, etc. So now we have machine-readable data, and we can process it. So our goal is to make some really good database with all the data that we can extract from these documents and photographs, and connect it together all the data that are written inside. We want to provide full text search for all the fieldwork reports and documents. We want to do the mentioned RAG application, that's the vector search, because we don't want to search by some exact phrases. We want to search with some thoughts and not exactly specified sentences that are occurring in the text. Also, we want some graph relations between the informations that are inside documents, some object detection. For example, if I have some photograph of my own find, I want to search for similar finds that we have in the database, and also some similarity search, which is we want to find the most similar photograph or find that we have in this database. So that's our goal, and this is how we are doing it by hand for now in our institute. So like I said, we have some metadata, and we have text of the scanned documents. As you can see, it's semi-structured data. So we can see there is some description of grave number 18, and under it there are description on finds inside that grave. So we want to connect these artifacts that are in those graves and make really good structured data from these fieldwork reports. Also, we need to connect these photographs to these documents, because a lot of photographs we have, they are not related directly into the text. But we have some metadata from these photographs, like inventory numbers or descriptions, or just information who took this photograph. And with that, we are looking inside these documents. We are trying to find these inventory numbers or the specific descriptions that suits these photographs with the help of a metadata. For example, if we know that the author of this photograph is also the author of this document, it's most likely to be inside the same document. Also, we are going through these documents and we are searching if some of these photographs aren't directly inside these fieldwork reports, so we can connect them. So that's it, task done. But it's really inefficient, and with this approach, it would take 10 to 20 years to finish this transformation of data from scanned old documents and photographs into some structured database. So we need some help of some algorithms, and we can easily use the methods that Benjamin mentioned to extract this information and transform it into our structure. We are using some methods of natural language processing and large language models. You don't need to use large language models for everything. You can just use some name entity recognition and looks for some specific parts of the documents, because it's semi-structured data. So if we, for example, find some inventory numbers, like I mentioned here, 08757, we can connect it to some other information that we have in relation to this inventory number. Or we can look inside the text and look for some period or materials, etc. So we can get a lot of information from the text by just simply look at the important parts of the text that are relevant to us. And also with the era of large language models, this is so much easier because we can just throw this in the model, and it will parse the data, and as a result we have some structured data that we can use. As I said, we can make some full text search on the scanned documents. So when we have photographs and we know the inventory number of the photograph, we can search all the documents for the specific inventory number or some other metadata, and hopefully we get some result that this specific photo is related to this fieldwork report, to this grave, and to these specific details. Also, we don't need to search manually through the fieldwork reports and look for the photos that are occurring in that documents. We can simply use deep learning algorithms like convolutional neural networks, etc., to find similar images inside these documents. So we don't have to search them manually. We just run this algorithm, and it will tell us that this brochure is likely to be in maybe these 3 documents. Also, we are connecting in our database these photographs with the text from these fieldwork reports. So when we have a lot of data in our database already processed, we have connected text with photograph. So it is possible to search by text. So if we put some paragraphs from the fieldwork reports into this algorithm, it will search for images that are that this paragraph describes. Also, when we can retrain our own models and made some stable diffusion model, so we can generate some probable image from the text that we are looking for, and then search with this generated image for other images that are related to this brochure. So that's just some that's task done, but much faster, and we can now focus on the more exciting things we can do with these data. So the recapitulation, we made optical character recognition, so we can provide full text search for all these documents. We can embed this text into vectors and search for semantic meanings of our sentences, etc. We have databases with relations, and we have graph databases that allow us to connect information between these artifacts and graves and some other areas. Also, we have photographs connected to specific part of the text. So we have photograph, we have a description that was made by some archaeologist. So we know that these photographs or these artifacts have some datation and basic description, basic classifications, some materials, etc. And with that, we can make some more, we can extract more data than we have now, because we can ask questions like, how many Roman broch was in the grave with some kind of sword? Or we can ask if someone already find these type of artifact, or if you provide some photograph with your own new find, we can search our database for every other most similar artifacts, and you can get probably the period, maybe other information, classification, etc. So that's just the first step of how we can enhance our data in the later processes. But I think that's for another presentation. And thank you.